Today we will be dealing with the classification type of algorithm. Last class we have seen the regression. We have finished the linear regression, simple linear regression we have seen. We have seen multiple linear regression also. Okay, so all those algorithms comes under regression type of algorithms. That means, uh, so I have explained in one of my previous session, the supervised type of algorithms can be divided into regression type and classification type based on the target variable or output variable. Okay, so based on the output variable y, we can classify the supervised algorithms into regression type and classification type. Now if regression type, when the y is continuous, and the classification type when the y is categorical. Now, what is continuous means? So, last class we have seen the salary prediction. It's continuous in nature. 1 lakh, 1,50,000, continuous in nature. But classification means, so example, cancer, yes or no, yes or no. That means one or zero. Okay, so this first one, yes category or category A, we can say. Second one, B category, that is no category. Okay, so like this, if you have a category, different categories of outputs, we can have classification type of algorithms. But in regression type, some continuously varying outputs. But see here, the output is, it is not continuously varying. We have only two categories: category one or category A and category B. It is not continuously varying. So that type of output is known as categorical output. Okay, so this is of binary type. Binary means one and zero only. Instead, you can have multi different categories also. Okay, different categories means like in the case of tree, different trees are there, different categories of trees are there. So like that, we can have different categories. But in the case of cancer, only yes or no, two categories only. In the case of trees, different categories are there. So these are all comes under categorical type of output. Now, if the output is of categorical type, we need to go for classification type of algorithms. Now, why can we use regression type? I will be explaining in a short period of time, after some time. Okay, why can we use regression in these types of in these cases? That means when the output is of categorical type. So I will be explaining about that later. So when we start with one of the algorithm, I'll be explaining why can we use regression type of algorithms for classification. We can use regression also, but what are the problems I will be explaining later. Now, this is the thing we are going to see today: classification type of algorithms, and we have seen that classification can be binary classification. Just now I explained uh, when there are only two classes, yes or no, that is binary classification. Then multi-class, more than two classes. So just now I explained. Now these are the different types of classification algorithms: random forest, decision tree, logistic regression, support vector machines. Okay, so first of all, we will see the most common logistic regression. Then we will see decision tree, random forest. Then support vector machine also, if time permits. Okay, so first of all, a logistic regression. Is it okay for you? Are you able to understand? What is classification? Are you able to understand? Okay. Now we will see the first type, the logistic regression algorithm for classification. Now, just now, as I said, we can use it for classification. See, you have two classes, class A, class B. Now, by using logistic regression, we can have the classification between these two classes. See, all the data points have been classified into class A and class B. Now, this type of operation can be performed by using logistic regression. Logistic regression is used for classification. It's a supervised machine learning algorithm for classification. Example is uh, email spam or not. Now we need to determine whether the received email is spam or not. So for that purpose, we can make use of this logistic regression. Okay, so for checking the received email is spam or not, we can use this logistic regression. So spam means it's class A or it's a spam class. Now not spam means the second class, class B. So like that we can have classification. Now other examples we have just now discussed. Cancer, yes or no. Again a classification, different types of trees. It's a multi-class classification, and today we'll be seeing the binary classification between two classes, class A and class B only. Now, as just now I explained, here the target variable, that means the output y or target, should be discrete value, one or zeros, one or zeros. Okay, and it should not be continuous. Now, if the output is continuous, we need to go for linear regression. If it is of categorical and discrete type, we can go for logistic regression. Okay. Now, assume you have a data set here. Now, here, this data set is uh, the data set of different persons having different ages and whether these persons have insurance or not. Now, the first person with 22 years of age, he has insurance. Sorry, he do not have insurance. Okay. Similarly, the person with the 25 year of age, 24 years, she also, he or she also doesn't have insurance. Similarly, for different persons, see this person having 47 years of old, he has insurance. So similarly, you have a data set like this. Assume that you have a data set like this. So we have a different person's ages. First person 22 years of age, second person 25 years of age. Now corresponding to age, whether that person has insurance or not. Zero means no insurance. One means he or she has insurance. Assume that this is a data set we have now. Now, when you plot the scatter plot between age and insurance, so you can get a plot like this. See, only zeros and ones. So that means the output is only 0 and 1. Discrete type, 0 and 1. Okay, so when you plot this data set in a scatter plot, you will get a plot like this only. Because see, this is the output. Output is insurance. Output is only 0 and 1. Okay, so you should be getting a scatter plot like this. Okay. Now, can we use linear regression here to find out whenever a new person comes with an age of some 50 years of old, whether that person is having insurance or not? So that is the thing we need to find out. So for that purpose, can we use linear regression here? Now, what is linear regression? We will fit a line like this. Okay, so we should fit a best fit line like this. Now, assume that this is the best fit line. Now, you think about the error this particular line possesses. Now, for these data points, we will get the error is very less only. But what about these points? The error is very much high. So, does this line is able to produce good output? No. So that is the problem with fitting a line here by using linear regression. Now here itself you can see, so here I have plotted a line just like the line I have shown here. Uh, See, you have a line here. Assume that this is the best fit line. Assume that this is the best fit line. And uh, as I told you, these particular points, the error between the predicted line, the best fit line, and these points is very much large. Okay, so this will give you erroneous output. So when you use linear regression to predict the output. Okay, so here itself you can see. Now this person corresponding to this person, what is the predicted output using linear regression? Assume that you have a threshold value zero point 0.5. Assume that you have a threshold value zero point 0.5 and all the values above zero point 0.5 will be belongs to this class. All the values below zero point 0.5 belongs to this class. Assume that this is the algorithm we have. We are using a linear regression algorithm and we are specifying a target, sorry, a threshold zero point 0.5. All the values above zero point 0.5 will be classified as class 1. All the values below zero point 0.5 will be classified as class 0. Okay, so here we are trying to use linear regression for classification. Okay, not for prediction. Now, in order to have a classification, there should be a threshold value. Now, see, for this particular data point, what is the predicted output? It is below the threshold value, zero point 0.5. So, this is classified as zero class, but it should be the class 1 actually. So, that is the problem when we use linear regression for classification. Okay, again I will explain. We have this data set. Okay, the target is zeros and ones only. Okay, now you are plotting those points in a scatter plot like this. In a scatter plot like this. Now you are trying to make use of linear regression for classification. It's actually for prediction, but we are using that, we are trying to use that linear regression for classification. Now, how will you classify? It should be classified as a, the data point should be classified as a class 0 or class 1. Now, for that purpose, there should be a threshold value. All the values above this threshold will be classified as first class, that means class 1, having insurance, and all the values below that threshold will be classified as class 0, not having insurance. Okay, so we have the line here, best fit line. Now, see, this is the actual output for 40 years of old. This person actually is having insurance. One, output is one. So he has the insurance. But see, in the line, see, the predicted value is here only. Now this value is below zero point 0.5. So that means this actually belongs to class 0. So this is actually wrong. This should be class 1. This data point should be class 1. But it is classified as class 0. So this is the problem if we are using linear regression for classification. Okay, so this is the problem we will encounter when we use this linear regression for classification. This is because the data, the error between data points and the regression line is very huge compared to the previous linear regression case. Okay, so this is, sorry, because of this, we cannot use the linear regression for classification. Now, instead of this, instead of this, if you fit a line like this, an S-shaped curve, instead of a line like this, if you are trying to fit an S-shaped curve like this, will it be a good? Will it produce good output? Yes, because you can see this particular curve approximates the actual distribution here, or we can say this particular curve fits almost all the points. Fits almost all the points. Now this particular line, it's actually an S-shaped curve, reduces or find out or gives a best fit curve compared to this particular line. Now see, all the points belongs to the class 1. See, we have a, you can see it here. Now see, we have these points belongs to class 1. These points belongs to class 0. Now, if we use this particular S-shaped curve, now when we have the classification, you can see that all the points, just a second, we can see that, see, for example, this point. Now, the output is for this point, the output will be this particular point. Now, see, this particular point, this particular value is above the threshold, zero point 0.5. So, this will be definitely classified as a class 1. Similarly, all these points will be classified as class 1, and all the points below the threshold value will be classified as class 0. So, this looks nice compared to this type of straight line. Okay, so this is the reason we are not using the linear regression for classification, but we are using the S-shaped curve for classification. Now, this particular S-shaped curve is actually known as the sigmoid function. So, instead of a simple line, we are using a sigmoid function here, which is nothing but an S-shaped curve. So, I think this is clear to you. The only point is for classification, so don't get confused. Here, the only point is for classification, we are not using linear regression, but we are using an S-shaped curve. That S-shaped curve is a sigmoid function. Okay, now here is the S-shaped curve. Another illustration, here is the S-shaped curve. Now, for the classification purpose, we should have a threshold value. Now, all the outputs above the threshold will be, all the data points above the threshold will be classified as class 1, and below the threshold will be classified as class 0. So for that purpose, we should have a threshold, typically zero point 0.5. Now, assume that the sigmoid function is y is equal to 1 divided by 1 plus e power minus x, where x is the input. Now, you are giving an input x, that x is the input. Now, we will calculate 1 divided by 1 plus e power minus x. That is the sigmoid function y of x. So that means the y we are getting here, which is equal to 1 divided by 1 plus e power minus x, where e is the Euler's constant 2.718. X is the input. Now assume that you are getting the y value which is zero point 0.8. Okay, so here the thing is, you will be given with an x value. Our aim is to find out whether this x value corresponds to class 0 or class 1. This is our aim. We need to find out whether the x value, that is the input value, belongs to class 1 or class 0. For that purpose, we are applying this x value to this sigmoid function. Now, the sigmoid function calculates an output which is assume zero point 0.8, y is equal to zero point 0.8. Now that zero point 0.8 will be compared with the the threshold value zero point 0.5. Now you know that the zero point 0.8 will be always, zero point 0.8 is greater than zero point 0.5. So this output will be classified as a class 1. Similarly, for another input, assume that you have y is equal to zero point 0.3. Now, as you know, this zero point 0.3 is very much below zero point 0.5. So this particular point will be classified as class 0. So this is the operation takes that is taking place in uh, logistic regression. Okay, actually, this is pretty complex compared to this. I explained in a simple way. It's actually complex, not this much simpler. Okay. Okay, so um, the sigmoid function produces an S-shaped curve, and it will convert any number and map it into a numerical value between 0 and 1. So that means, see here, you are getting zero point 0.3, zero point 0.8. So we will map every input values between 0 and 1. It can be zero point 0.1, zero point 0.2, zero point 0.3, zero point 0.5 up to 1. Now, all the values below zero point 0.5 will be classified as belonging to uh, the class 0, and all the values above zero point 0.5 will be classified as class 1. So that means here we are getting probabilities between 0 and 1 means probability only. So this is the probability zero point 0.3. Okay, so don't get confused. Uh, I'm making it simple. So here the thing is, take the input, apply it into this equation, get the value y or y of x. Now plot that value here, or check that value whether it is less than zero point 0.5 or greater than zero point 0.5. If it is less than zero point 0.5, it should belong to class 0. If it is greater than zero point 0.5, it should belong to class 1. That's it. Simple. Actually, this is far more complex. Okay. Now, the exact thing is, I will tell you the exact thing, but I will not explain it here. Actually, instead of this x, we should find out one more relation. Okay, actually, that is the linear regression equation. That we should substitute here instead of this x. That is the actual procedure, but I am not discussing that here. Okay, I am making it simple. Any doubt up to this? So this much is enough to understand the logistic regression. Now, why it is logistic regression means the logistic or sigmoid, both are same. Another name, logistic function or sigmoid function. That is why it is known as logistic regression. Previously, we have used a line. That is why it is known as linear regression. But here it is logistic because we are using a logistic function or a sigmoid function. Any doubt up to this? Any doubt up to this? But in programming, when we program this logistic regression, there is no need to find out these transformations and all. Instead, we can call only logistic regression directly from the sklearn library, and you can work it out. Just you understand, instead of a line, we are fitting a logistic function, a sigmoid function. That's all. Now all the fitting the threshold definition, all these things will be done by the function itself that we will call from the sigmoid sorry, the sklearn library. Okay.
Sir,
Yes, yes.
sir, there is applicable only for the one threshold value. That means
Yeah,
above and
this is for
okay.
binary classification. That means two classes only. Okay, this is binary classification. It is for two classes only, class 0 and class 1. Now, if you want to go for multiple classes, the threshold selection will be different. That will be taken care of by the function. Okay, so for example,
Yeah, thank you, sir.
between 0 and some point 2, it belongs to one class. When point 2 to point 4, another class. So like that. Here it is only binary classification, two classes only. Okay. So the thing is, we can use the linear regression for classification, but the output we will be getting is what to say. It is not up to the expectation. So that is the reason why we are going for the logistic regression using a sigmoid function. Okay. Now some performance metrics for classification. Performance metrics for classification. And now before that, we will. Okay, so these are the performance metrics: accuracy, precision, and recall. Recall is also known as sensitivity, then specificity, then F1 score, then area under curve, AUC, receiver operating characteristics, ROC. So these are the main performance metrics for classification: accuracy, precision and recall, specificity, F1 score, and AUC ROC. Okay, so before that, we should study something known as confusion matrix. Before explaining all these parameters, we should know about a something called as confusion matrix. Now, for that purpose, just see this Excel sheet. This is this for explanation purpose. Now assume that you have some customers here having these customer IDs, and these are the outputs. Assume for explanation purpose, these are the actual outputs. This customer, the output is this. Assume that this is the output for this particular customer. So that means this customer belongs to this particular class. Similarly, for this customer, this is the output. Zero is the output. Assume that these are the outputs and these are the predicted outputs. So we are going to study the performance of the algorithm, right? So these are the actual outputs and these are the predicted or classified outputs done by the classification done by the logistic regression, and we have obtained these outputs corresponding to these customers. That means the customer having customer ID 1549, the actual output is he belongs to class 1, the predicted output is class 1 itself. Similarly, this is class 0, the output is 0, but for this one actually it should be 0 but predicted as 1. Okay, so like this, I have listed some actual outputs and the corresponding outputs by the logistic regression or any type of classification algorithm. May not be logistic regression. I have shown some of the classification algorithms like random forest, decision tree. So it may be the one of the classification algorithms. Okay, need not be logistic. It can be any it can be output of any one of the classification algorithm. Okay, so assume that these are the actual outputs and these are the predicted outputs. Okay, now we are going to see the confusion matrix. So this is for performance analysis only, testing purpose, performance analysis only. Now see, this is the actual output, this is the predicted output. So this is true positive. Positive means 1. So this is true positive. It is positive actually, predicted truly as positive. So it is true positive. Now this is actually negative value, that means 0. It is predicted correctly, that is true negative. So similarly, this is also true negative. But see here, actually it should be 0. Actually it should be negative, but predicted as positive. So we can show it as false positive. Got the point? Why? What is this false positive? This should be 0 actually, but predicted as positive. So that is why this is false positive. It should be negative actually, but predicted as positive. So this is false positive. Now see, this is the actual output, but predicted as negative. So it is false negative. It should be positive actually. Again, this is a true positive. This is true negative, but this should be negative actually, but predicted as positive. So it is false positive. Got the point? So we are finding out the TP, TN, FP, FN here like this. Okay. Any doubt up to this? What are true positives, true negatives, false positives, and the false negatives? Once again, take this one. This should be positive, but predicted as negative. So it is false negative. False negative. We are getting negative. It is false. It should be positive actually. See here, we should have negative, but predicted false, falsely as positive. So false positive. So like that, true negative and the false negative also. This should be positive actually, but predicted as 0. It's a false. So false, and we are getting negative. So false negative. It should be positive actually. So this is the way in which we categorize the outputs into true positive, true negative, false positive, and false negative. Now confusion matrix is, it's actually a matrix having values plotted against predicted and actual output, actual and predicted output. Okay, I will enlarge this. Okay, now see actual output 1, 0, predicted output also 1, 0. Okay, so 1 1 means it is true positive. See here, 1 1 means it is true positive. 1 0 means it is false positive. 1 0 means sorry, not like that. Uh, we should start from actual to predicted. Actual, if it is 1 and 1, it is true positive. If it is actual is 0 and predicted is 1, it is false positive. Actual is 0 and predicted is 1, it is false positive. Actually is 0 and predicted is 1 means it is false positive. False positive. Actually is 1 and predicted is 0 means, see, actually is 1 and predicted is 0 means it should be false negative. Similarly, actual 0, predicted 0, it is true negative. So this is actually the confusion matrix, and what we have to do is we should fill up these. How many true positives are there? How many false positives are there? How many false negatives and how many true negatives are there from the data set we have and the predicted output we have. Okay, now see the data set and the predicted output and see the classification. How many true positives are here? How many true positives are here? By, you can count it: one, then two, then 3, then 4. So 4 true positives. How many false positives? This is 1, 2, 3, 4. Sorry. Okay, 4, then 5. So 5 number of false positives. Similarly, you count false negatives and true negatives. So these are the values corresponding to true positive. The value corresponding to true positive is 4. Similarly, 5 number of false positive, 2 number of false negatives, and 6 number of true negatives. Now this is the confusion matrix, actually actual confusion matrix. I will copy it and paste it here. So this is the actual confusion matrix: 4 5 2 6. Okay, so I have detailed here what is true positive, true negative, false positive, and false negative. I already explained, so I'm not explaining it again. So we have the true positives, negatives, false positives, and false negatives. Now the first parameter. Now, any doubt up to this? This is an important thing because, of course, finding out the performance SCADA is an important thing when we study any of the algorithm. Any doubt up to this? Now, usually you need not do all these things. You can do all these things in Python in using sklearn. So it will give you the values directly without doing all these calculations. There is a simple line of code you can use. Confusion matrix. You can call from the sklearn.metric library. So we will see it later. But for the understanding purpose, I'm explaining it. Okay, so I will proceed. Now I have these values. 4 as true positives, 5 as false positives, 2 as false negatives, and 6 as true negatives. Now the accuracy, the equation for, see, actually this is the confusion matrix. It's a table used to describe the performance of a classification algorithm model. Okay, it's a table to describe the performance of a classification algorithm. And now see, what is the equation for accuracy? Equation for accuracy is Tp plus Tn divided by Tp plus Tn plus Fe plus Fn. Now, what is the actual meaning of accuracy? What is the actual meaning of accuracy? How many are correctly classified out of the all data sets? How many are correctly classified? That is what is the accuracy. Now, how many are correctly classified here? True positives and true negatives only. Remaining all are false. Okay, only true positives and true negatives are the correctly classified outputs. See here, this is the correctly classified output, true positive. True negative, correctly classified output. But see, false positive is actually not right, it is false. Similarly, the uh, f- uh, sorry, false negative also is again false. It is not true. So that means these values, true positive, true negatives, are the truly classified outputs. So accuracy means truly classified output. That means TP plus TN divided by the total number of outputs, total classifications, TP plus TN plus FP plus FL. Okay, so that is the accuracy. Now, when you do that, here in this example, the TP is 4, TN is 6, then the total is 4 plus 5 plus 2 plus 6. 4 plus 5 plus 2 plus 6. When you calculate it, you will get some value. Now I obtained it as 58.882. So this is the accuracy of the classification we have done here as an example, just for illustration purpose. So accuracy, from the name itself we can identify what is the accuracy. How many are correctly classified as positives and negatives? That means true positive, true negative, out of the total classification done. So total classification include everything: true positives, true negatives, false positives, false negatives. So that is why TP plus TN divided by TP plus TN plus FE plus FN. So it is something around 58 I am getting in this case only. Okay. Now next one is precision. Precision means TP divided by TP plus FP. Now, what is this TP? True positives. How many are true positives out of the positively classified outputs? How many are positively classified? Positively classified means it can be true or false. Okay, so how many are truly positive? That means TP divided by total number of positively classified outputs. TP plus FP. FP is also classified as positive, but it is false. What to do? Anyway, it is classified as positive. Now, out of the positively classified, how many are true positives, truly positive, or how many are true out of the positively classified outputs? So it is TP divided by TP plus FP. Now again, when you substitute these values from the matrix, confusion matrix, here in this equation, you will get some value. Okay. Now again, recall. Recall means you can see from here. So, what is the difference between precision and recall? Now, precision means out of the positively classified, how many are true positives? But recall means how many are truly positive out of the actually positive. Actually positive means true positive is actually positive, false negative also is actually positive, but it is falsely predicted as negative. So Fn is actually positive only. It should be positive. See, Fn means it should be positive. You can see here Fn means it should be positive, but classified as 0. This should be positive actually. That is why I have taken this in the denominator. I have taken Tp plus Fn. Tp means it is true only, no doubt about that. But Fn also should be positive, but classified as negative falsely. So out of the total positives, how many are correctly classified as positive? True positives. That is the recall. Okay, so this something around 66 I'm getting. Now this is the difference between precision and recall. Now precision means how many are truly positive out of the total positive, totally classified positives. But recall means how many are truly positive out of the total positives. Actually, it should be there. How many total positives are there? Out of the total positives, how many are actually positives? Classified. How many are classified as actually positives? I think you got my point. Now again you have F1 score. F1 score is actually the we have this equation 2 into precision into recall divided by precision plus recall. It is again a metric. Using precision and recall you can get this value, and the value I'm getting is 53.33. So these are some of the important metrics. If you want these informations, you can go for this metric. If you are satisfied only with the accuracy, you can stick on to accuracy. Or if you need other parameters also, you can go for these parameters. But my suggestion is you need to calculate all these parameters. Accuracy may not be accurate always. Accuracy will be accurate, but using the accuracy only, we cannot find out the exact performance in some of the cases. Okay. Then one more is there. I think when I see one more is there, specificity, and one more is there, AUCROC. So there are two more pending, specificity and AUCROC. And here is the equation for specificity, Tn divided by Tn plus Ft. Now, see what is this specificity? You compare with recall. Recall I have just now explained. Recall. Yes, recall means Tp by Tp plus Fn. How many are truly positive out of the positive things? But see here, specificity means how many are truly negatives out of the negatives, total negatives. Total negative means this Fp is also negative. This is negative. Now, how many are truly classified as negative? So this is specificity. Is the ratio of true negatives to all negative outcomes. That's now if you are interested in calculating this, you go for it. That's so that is specificity. And the next one is AUC, the area under the curve, and ROC, receiver operating characteristics. Now you will have a curve like this. So this is the ROC curve. This is one ROC curve. This is the next ROC curve. This is the next ROC curve. Now under which what is the area? That is the AUC, area under the curve. Okay. So for this particular curve, under this how much area is there? Total area. That is the AUC. Under this ROC. That is AUC ROC. Area under the curve. What is that curve? Receiver operating characteristics curve. Is one of the important evaluation metrics for checking any model's performance. Okay, it is plotted between FPR and TPR. It is false positive rate and true positive rates. So these are the equations for true positive rate and false positive rate. Now you can easily recognize it is TPR is TP by TP plus Fn. There are some definite formulas for this. You calculate TPR, FPR. Now, FPR is on x-axis, TPR on y-axis. Plot the graph. That will give you the ROC. Now find out the area under the curve, that is AUC. Okay. Now, normally, if the AUC value, if it is less than zero point 0.5, the model is not a good model. It is worse than a random guessing model. That is worst model, we can say. It should be greater than zero point 0.5. That means it should be, this is the ROC curve for zero point 0.5. This is the ROC curve for zero point 0.5 AUC. So normally the ROC curve should be like this or like this. It should be always greater than the this diagonal line having AUC zero point 0.5 or larger. Okay, it can how much maximum you can obtain, you can that much good the model will be. So the model having this ROC cara will be better compared to the model having this ROC cara. Okay, so this is the best model we can say. So that means AUC can approach up to 1 maximum. That means you can say it's a good model, maximum good model. Okay, so it should not be less than zero point 0.5. AUC should not be less than zero point 0.5. So a greater value of AUC denotes better model performance. So AUC measures how well a model is able to distinguish between classes. That means it is showing the performance. So how the classifier is classifying things. That is the performance matrix, AUC. It should be calculated under the ROC curve. Now, ROC curve will be plotted using TPRS y-axis and FPRS x-axis. FPR on the x-axis. Now, FPR TPR will be calculated using these equations.